So we're doing this system of two blocks being pulled. Now the pull force pulls on the rope here, and then there's a force transferred along the rope which pulls on M1, but M2 is being pulled back by T2 because there's a tension force pulling back on that, and there's M2. So they're all being both dragged by this pull force, and then there's frictional forces pulling backwards. And M2, by the description, has a 9 Newton frictional force. So we drew in a free body diagram here of a frictional force pulling back on it, and a tension 2 pulling it forward. And then we have a T2 pulling back on M1, as well as a frictional force, because it has a 15 Newton force pulling back on it. And then we have T1, that's a T1 pulling it forward. Okay? So we've drawn the two free body diagrams here. This is where it gets a little bit trickier than the other previous examples, because we've now introduced friction. So we'll start with the system. I'll start right over here, because it looks like I might need room. The system. The mass of the system, easy. It looks like it's 27, right? No, 8 kilograms. Here is the trickier part. What is the force on the system? We want to add up all the forces on the system. Well, there's a pull force on it, and it's pulling on the rope, which is transferring it all the way along. So there's a tension of that pull force all the way along that rope. So T1 is going to equal the pull force. Because that's what a rope does. A perfect physics rope just transfers that force all the way along. Okay? So on this system, this is the direction of acceleration. Let's look at all the forces that are highlighted. And we ignore tensions, because a tension is a push-pull one. So there's a pull force, F pull, and there's two frictional forces pulling back, F1 minus F2. All the tension forces are internal. They push and pull back and forth, so we ignore them. Could you write T1 instead of F pull? Sure. Would it be wrong? No. I'll allow that because it's kind of external. It's not in between the two blocks. So I'm just going to do what the sum of the forces is. The sum of the forces is the pull force, which is 64 newtons. Subtract frictional force on number 1, which is 15 newtons. Subtract the frictional force on number 2, which is 9 newtons. So what is the force? What's 64 minus 15 minus 9? 40. Okay, now we write down Newton's second law. I like doing it in blue here to keep the pattern up. F net equals ma. Add up all the forces, it must equal ma. The sum of the forces, go to green where I'm filling in the data. The sum of the forces is 40 newtons, and that has to equal mass, which is 8 kilograms, times the acceleration. Therefore, the acceleration of the system is 5 meters per second squared. That's 40 divided by 8. Is that okay, folks? No? Okay. So let's do the one with the less forces on it to begin with. The sum of, write down Newton's law, F net. The sum of the forces, sorry. Sum of the forces equals F net, which equals ma. The forces on it are T2 minus the frictional force. That equals MA. Does someone want to tell me why it's T2 minus the frictional force and not frictional force minus T2?
It's going that way.
It's going to the right. So T2 is winning, so we take T to the winning force, subtract the losing force. Why don't we include T1? T1's not in the free body diagram. Why don't we include the force, pull force? It's not in there. We only include the forces that are in this free body diagram. Okay, so T2 minus the 9 newtons is equal to the mass, which is 3 kilograms, times the acceleration, which was 5 meters per second squared. So T2 is equal to 15 plus 9. So T2 is equal to 24. How's that? Did I lose someone? I can walk away and have all the answers. If this is multiple choice and you had to figure things out, walk away, you're done. Unless you need to do that check. You probably should anyways. I haven't solved for T1 yet, so I'm going to check T1. Oh no, we have checked. We have already had T1. It's the pull force. Oh, then I guess check T2. Because that's what we just solved. We have everything. Just check what we just did. This is going to be a more difficult one. Why? Because there's 3 forces acting in that yellow highlighted area. Sum of the forces equals F net, which equals MA. The forces is T1, subtract T2, subtract frictional force, equals MA. So the F1 is the pull force, which is 64 newtons. Minus T2, we're going to calculate that again. Minus the frictional force, which is 15 newtons. That has to equal the mass, which is 5 kilograms, times the acceleration, which is 5 meters per second squared. Isolate T2, and we'll get T2 is equal to 64 newtons, subtract the 15 newtons, and 5 times 5 is 25, so we'll have to also subtract the 25 newtons. And if you do that math, let's just do a little scroll here just to get rid of that annoying message, hopefully. T2 is going to equal 64 minus 15 is 49, minus 25 is 24. Yay! It checked out. Red squiggles. Check, check, smiley face. Yeah, that's a lot of work.